This is the video for 3.7, absolute value equations and inequalities. There is no new vocabulary for this lesson. However, I did say before watching this video, I want you to think back to what the definition of an absolute value is. And an absolute value is how far a number is from 0 on a number line. So remembering that, let's go to our examples. Okay, so let's look at example number 1, solving an absolute value equation. So if I say, what are the solutions of the absolute value of x plus 2 equals 9? Here's the goal, and take notes as I'm explaining things. Take notes, pause the video, and write down what I'm saying. This is what you always need to do. You want to get the absolute value bars by themselves. So what would we do here? I want to get this plus 2 away from the absolute value of x. I want to isolate the absolute value. So what am I going to do is I'm going to subtract 2 from both sides. And once I subtract 2 from both sides, I get the absolute value of x equals 7. Well, now you have to think, what are the possible values of x? X can be 7 and x can be negative 7. Why? Why are there two solutions here? Because both values of x will make this equation true. Think, the absolute value of 7 is 7, and the absolute value of negative 7 is 7. So both solutions are going to make this equation true. So there are two solutions to this. Okay, so now let's go to the next one. What are the solutions of 3 times the absolute value of x plus 2 equals 11? So what did I say your goal is? What are you trying to do? You're trying to get the absolute value by itself. So I want to get everything away from the absolute value. I want to get that by itself. So where do I want to start? I want to go ahead and subtract 2 from both sides. And once I subtract 2 from both sides, I'm left with 3 times the absolute value of x equals 9. But I don't want to know what 3 times the absolute value of x equals. I want to know what the absolute value of x equals. I want to get the absolute value bars by themselves. So that means I need to get this 3 away from it. So I want to undo my operation, and so I want to divide both sides by 3. And once I divide both sides by 3, I'm left with the absolute value of x equals 3. And so, what are my solutions of x? My possible solutions of x are going to be 3 and negative 3. My goal is I want to get the absolute value by itself. So I want to undo my operations until my absolute value is by itself. And if you need to rewind this and watch it again, please do so. Okay, so now let's look at the next one. My goal is still the same. I want to get the absolute value bars by itself. And so I have 2 times the absolute value of x plus 2 equals 10. But I don't want to know what 2 times the absolute value of x plus 2 is. I want to know what the absolute value of x plus 2 is. So what am I going to do? I have to get that 2 away from the absolute value. So it's connected through multiplication. I want to undo that operation. So I'm going to divide both sides by 2. And once I divide both sides by 2, now I have the absolute value of x plus 2 equals 5. Okay, I'm going to show you what I did here, and I want to explain what I did. What I did was I took what was inside the absolute value bars and I set them both equal to different numbers. I said, well, x plus 2 equals 5 and x plus 2 equals negative 5. But why did I do that? And then I solved for both. And there are my two answers. There are my two solutions. But why did I do that? Well, let's think about what let's think about what the absolute value of x plus 2 equals 5 means. This means that the distance on a number line from x plus 2 to 0 is 5. Because think about what absolute value means. Absolute value is how far a number is from 0 on a number line. So this means the distance on a number line from x plus 2 to 0 is 5. But there are 2 points that are 5 units from 0, 5 and negative 5. So I have to take this and I have to set them equal to both. So x plus 2 is going to equal 5, but x plus 2 is also going to equal negative 5. So go ahead and watch that again if you need to, and then pause the video and try that on your own. Okay. When you do the on your own problem, you get n equals 5 over 3 and n equals negative 1 over 3. Because what did I have to do first? I had to get the absolute value bars by themselves. So the first thing I needed to do was add 5 to both sides. And once I did so, that's what I got. But now I need to set this 3n minus 2, I need to set it equal to 3, and I also need to set it equal to negative 3. And let's think about why I need to do that, because what is this saying? This is saying that the distance on a number line from 3n minus 2 to 0 is 3. And there are 2 points that are 3 units from 0, 3 and negative 3. So I have to set them both equal. I have to set this equal to both. I have to set this equal to 3, and I have to set this equal to negative 3. And then I need to solve for both. Okay, so now let's look at the next one. Again, my goal, actually, let me move this up. My goal is still the same. I want to get the absolute value bars by themselves. So I want to get everything away from the absolute value bars by undoing operations. And so where am I going to start? I want to go ahead and start by subtracting 12 from both sides. And when I do so, that's what I get. And then I want to divide both sides by 3. I want to get those absolute value bars by themselves. Once I divide both sides by 3, that's what I get. But now let's think about this. I'm left with the absolute value of whatever, it doesn't matter, equals negative 2 over 3. It doesn't even matter what's inside of here. You can look at this, and because this is set equal to a negative number, you can stop right there and say no solution, because an absolute value can never equal a negative number. So go ahead and hit pause and work out the next one. Okay, when you work out the next one, you have the absolute value of 3x minus 6 equals negative 2. Again, no solution, because the absolute value of any number can never equal negative. But what did I do to get this? I said I want to get the absolute value bars by themselves. So what am I going to do? I'm going to add 5 to both sides. Now I'm going to show you how to solve an absolute value inequality involving a greater than symbol, or a greater than or equal to symbol. Whenever you have a greater than symbol, or whenever you have a greater than or equal to symbol, that is an or statement. that is called a disjunction statement. And so I want you to think about what the absolute value of 8n is greater than or equal to 24 means. This means that 8n is at least 24 units from 0 on a number line. And so now let's think about, in order for 8n to be at least 24 units from 0 on a number line, to be at least 24 units from 0, 8n can be less than or equal to negative 24 or greater than or equal to positive 24. So you have to solve both. So pause the video, read that, and look at that closely. But think about what I'm doing here. I'm taking the absolute value of 8n is greater than or equal to 24, and I'm saying 8n is greater than or equal to 24, or 8n is going to be less than or equal to negative 24. And then I'm going to solve both by dividing both sides by 8. And look at what happens when I graph it. I get an or statement or a disjunction. And both of these situations are going to be at least 24 units from 0, or once we divide both sides by 8, they're going to be at least 3 units from 0. So rewind that and watch it again, pause it, and study what I wrote there and think about it. But look at what you're doing in the process. Memorize the process, but try to understand what you're doing. And that pre-AP material that I gave you that is optional, that can help understand this process. Okay, so pause the video now and try the on your own problem. Okay, so this is the on your own problem. What I did was I set 2x plus 4. I said 2x plus 4 is going to be greater than or equal to 5, or 2x plus 4 is going to be less than or equal to negative 5. Because think about what this means. This means that 2x plus 4 is at least 5 units from 0 on a number line. And so to be at least 5 units from 0, 2x plus 4 has to be greater than or equal to 5 or less than or equal to negative 5. And so you know it's going to be an or statement whenever it's a greater than. And finally, example number 4, solving an absolute value inequality involving a less than or equal to symbol. A less than or equal to symbol will always be an and. That's a conjunction. It will always be an and. And this is how you solve these. You say w minus 2, well, you always get the absolute value bars by themselves, and then once you do that, I'm saying w minus 2 is less than or equal to 5, and w minus 2 is greater than or equal to negative 5. And then I solve both, and this is what I get. With less than or equal to, the variable is contained within one interval. So what I'm saying is w minus 2 is going to be both less than or equal to 5 and greater than or equal to negative 5. And the pre-AP material does an excellent job of explaining this a little bit deeper. It's deeper than I'm willing to go right now because I don't want to overwhelm you, but it explains that basically what this is saying is your answers are going to be plus or minus 5 from 2. But again, I'll let you look at the pre-AP material to better understand that if you feel ready for that. So go ahead and hit pause and do the on your own. And here's the answer. So I'm setting it up as h plus 3 is less than 5 and h plus 3 is greater than negative 5. And again, the pre-AP material will explain to you that this is saying that your answers are going to be plus or minus 5 from negative 3.